Hey everyone, so today we're going to be working on translations, specifically horizontal and vertical shifts, so moving up and down, left and right. We'll talk briefly about some stretching of our graphs, but that's going to actually be more in next unit. So what we want to talk about first here is horizontal and vertical shifts on a graph, and I kind of wanted to show you a general idea. So here's kind of the setup you could have. You could have a function where we're adding something on or subtracting on the outside. That looks like number 2 over here. You could have where you're adding or subtracting on the inside. That looks like number 3 on my Desmo screen. We're not going to do this last one, but we are going to talk about what if we have a times f of x. So if you want to fix that a little bit, we'll talk about that as well. So all I want you to see right now is what happens when we add or subtract something on the outside. All right, so here's my graph x squared. All right, so hopefully you can see it over here in red. That is the original x squared. So if I add in, okay, x squared plus c, okay, I want you to take a look what happens when I change that plus c value. Okay, so what if I change it to a positive number? What's happening? All right, so observe what's happening. It's moving up. The graph is moving up. Okay, when I'm started at 0, what if it goes to f of x minus c? F of x minus c is moving down. And again, I can turn off the red one so you guys can see what's going on. So here's my original, okay? And right there at 0, yep. And then if we do f of x minus a number, minus 5 moves us down 5, minus 6, minus 7, minus 8, all the way to minus 10, that just moves my graph up and down, okay? So plus c on the outside moves it up, minus c on the outside moves it down. Okay, so if you want to jot that down, we're over here. Okay, moves up c units, right? So if it was like plus 4, you'd move up 4. And if it's on the outside, it moves down if we're subtracting c units. Okay, what about this? What if I give you, so I'm going to give you another quadratic. We're going to talk about the purple one now. So notice it's right at 0, 0. Okay, what if I shift that inside? So notice I have x minus c on the inside. Okay, if I plug in a positive number there, like x minus 2, x minus 3, what's happening? Okay, notice, so this represents x minus 10 squared. Where am I shifted? I shifted right 10, all right? Versus this, take a look here, if I start back at 0, right there, okay, and I do x minus negative 4, minus negative 6, let's say, okay, now I am left 6, but notice that's going to actually be x minus negative 6 is x plus 6 squared. Okay, so that's going to be left 6, left 10, etc. So it's just shifting left and right. All right, so that is this piece right here. When it's on the inside, and it's minus a number, okay, it moves right c units. And when it's x plus a number, like x plus 6 really represents x minus negative 6, it moves left c units. Okay, so if it was x plus 4, we would move left 4. All right, and then that number in front, I wanted to show you guys that. If I started you out with something like this black parabola here, 1x squared, and that's pretty typical, right? What if I became more positive, like 2x squared, 3x squared, 4x squared? Notice it's not shifting, but it's becoming very narrow. And the reason that's happening is you want to picture, if you're pulling on the tops of this parabola, you're technically stretching it. So this is a vertical stretch, and the y values are being multiplied. So y values are being multiplied by 2, so it's growing twice as fast. I wanted you to notice, and again, we're not going to do too much of this unit. We'll do it a little more next unit. What happens when we're negative? Flips over that axis. So we have a negative in front, okay, that negative a. Now I'm still stretched out, but I'm actually stretched out going the opposite direction. So like negative 2 is growing twice as fast, but reflected over the x-axis. Okay, so if we want to jot ourselves a note, I'm actually going to close Desmos here. I think we're all set with that. Go to fully notability. Whoa. All right, so a f of x, it's a vertical stretch or shrink. Okay. Actually, the last one I want to show you, of course, now I have to bring it back. Desmos, come back. Okay, last one I want to show you, I'm sorry I didn't show this. What about if it was like a fraction, like right, oops, sorry, 0.3. I don't know if you guys can see that. it actually gets wider, like 0.1, 0.6. So interestingly, it actually is shrinking vertically, okay? Or it could be stretching if it's above 1. So again, I just wanted to show you that. We'll talk about it more next unit. So vertical stretch or shrink, okay? If A is negative, flips over the x-axis. Okay, so we're done with our exploring. Let's actually figure out what's going on and how to graph these by hand. All right, so if we move over to this little fill in the blank here, okay, what we're looking out for is what's going on inside. So inside, right, things that are inside is left and right. Things that are on the outside is shifting up or down. So x plus 6 is on the inside. When we add on the inside, we're moving left 6. All right, here's a double shift for you. Plus 2 on the inside, that means left 2. We're thinking opposite. Plus 1 on the outside, when we added on the outside, we went up 1. How about an absolute value moved left 3 and down 2? Well, left, again, it's kind of opposite of what you would think. Sorry, left, I pointed at the wrong one. Left is plus, okay, so x plus 3 on the inside. Down 2 is exactly what you would think. Subtract 2 on the outside. All right, and to finish up here, how about cube root of x minus 7 on the inside? Feel free to refer. Minus 7 on the inside meant right 7. And minus 2 on the outside, we actually just did that. That was down 2. Okay, and how about x plus 1 on the inside? X plus 1 on the inside is going to be left 1. All right, and the last one, x cubed reflected, okay, or flipped, would be negative x cubed. So again, this one, we'll talk about more next chapter. Don't worry about it too much, but still good to recognize when that's happening. Okay, so let's actually get down to business here. We're going to do 2 different types of examples. Number 1, I'm going to give you 3 points. We're going to translate them. Then the second examples here, we're going to actually graph some of these shifts. Okay, so first thing here, we'll do a couple of these, see how it goes. So f of x plus 1, this means left 1. That's the first thing you want to think of. So what does that mean when I move left 1? All my x values, I'm going to subtract 1. So instead of negative 2, 4, I'm going to be at negative 3, 4. Instead of at 0, negative 3, I'm going to be at negative 1, negative 3. And instead of 6, negative 1, I'm going to be at 5, negative 1. Okay, so let's try out example 3 here, actually. We'll save 2 for class. Okay, example 3, inside minus 5. That means right 5. Outside plus 3. That means up 3. Okay, so right 5 and up 3. Well, for every x value, go back to the originals, I'm going to add 5. So even though it looks like minus, this means right. So I'm going to be shifting to the right, meaning my x values are going to be adding 5. So instead of negative 2 plus 5, I'm going to be at 3. Instead of 0, I'm going to be at 5. Instead of 6, I'm going to be at 11. So I added 5 to each of those. How about up 3? What does that do to my y values? Up 3 would add to my y values. So 4 plus 3 is 7. Again, I'm going with my y values now. Negative 3 plus 3 is 0. Negative 1 plus 3 is 2. Okay, and we'll save example 4 for class as well. So that's when I have a set of points. Figure out what's going on with the translation and add that to the points given. Okay, so now we're going to try graphing some of these. You'll notice we have quite a few examples. We're not going to do all of them. Here's what I want you guys to think about, okay? When we are graphing these, the first thing you want to do is think of what's the parent function. This one is absolute value of x. And then I want you to think about what is the shifting. The inside here would mean right 2, the outside up 3. We have to get really comfortable with what those shifts are right away. My recommendation for graphing these is actually doing kind of shadow points, so shadow parent points. What I mean by that is graph your table for absolute value of x. We should know this pretty much off the top of our heads. 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. If you need to, write down the parent points over here. Okay, so what we could do is add to our values just like we did above. My recommendation is actually taking those points, picking a darker color here. Those are kind of shadow points. Taking your pen and going right 2, up 3. So from this point, right 2, up 3, I would end up here. This point, right 2, up 3, I would end up right here. Right 2, up 3, I would end up here. Keep going. Right 2, up 3, I would end up there. Right 2, up 3, I end up right here. Okay, so if you move each of those points right 2 and up 3, okay, you'll notice we get our new graph. And for absolute value, it's kind of nice. You can see that just if I move the vertex right 2 and up 3, I pretty much just graphed the same pattern, but shifted. Okay, so you do not need these yellow points. You can erase them. They should be pretty lightly drawn if you want to keep them there. But either way, the green graph is your final graph here. Okay, so let's try a couple more of these. I want to try, let's see here. I'll try number 3, and then we're going to try 2 more here. All right, so number 3, cube root of x plus 1. Okay, parent function would be cube root of x. Okay, what's the table for that if you need it? Table for that would be I'm plugging in perfect cubes, and I'm getting back cube roots. Okay, so again, in yellow or something very light, let's graph that. So 0, 0, 1, 1, 8, 2, 3, 4, 5, 6, 7, 8. 8 is our last one here. -1, -8. Okay, so there's my shadow points. Go back to your graph. I'm going to go with this green again. What's happening? It's on the outside. It's +1. I'm shifting up 1. So take every point, shift it up 1. And that green graph is what I want to connect here. And there's my final answer. So again, I'm using those parent points, those original points to help me graph this so that I can have a smooth transition into shifting, and it's not very difficult. I didn't have to memorize new points. I didn't have to change a table. Another option is you could just plug it in every single time for your table, but my recommendation is if you know those parent points, the shifting is so much easier than that, than actually taking each point and plugging it in. All right, so we're going to try one quadratic here. Let's try out this guy. Okay, x minus 1 squared minus 4. So first thing you want to do, decide that it's x squared is kind of your parent graph here. If you want to write out your table, -2 squared, -1 squared, 0, 1, and 2. And if I do this in yellow, remember this is that up 1 over 1, up 3 over 1. Okay, so up 1 over 1, up 3 over 1, up 1 over 1, up 3 over 1. 1a, 3a, 5a is what you'll hear me refer to that as. And the reason that's kind of nice is then this table becomes a little less relevant. I start at 0, 0, and I go up 1 over 1, up 3 over 1, up 5 over 1 if it fits on the graph. And then from there, I can just shift. So this means right 1, this means down 4. Okay, so I could go this way as well. Right 1, down 4, I start here, and I know the pattern. Up 1 over 1, up 3 over 1. Okay, up 1 over 1, up 3 over 1. I could also count from each point, but notice this is the graph exactly shifted right 1 and down 4 from every single point. Right 1, down 4, right 1, down 4. So up to you, but knowing that pattern of points, 1, 3, 5, is really going to help you graph this quickly. So, last one we'll do is example, let's do example 6 here. Okay, example 6 is a square root. So again, take your time here. Think of what is the original function. It's square root of x. What type of things do I plug in here? And again, knowing these parent tables is going to make your life so much easier. I plug in 0, 1, 4, and 9 typically. Square root of 0 is 0, 1, 2, and 3. I cannot plug in negatives, so I want to be careful. And this is my graph right now, 4, 2. Unfortunately, this is 8, so like 9, 3 is over there. Okay. And again, we always just try to plot as many points as we can. Typically 5 is a good number, but for square root, sometimes it's less. All right, go back here. What's happening? Okay, what are my shifts here? Left 2, down 7. Get really, really good at recognizing those. And again, this is 1, 3, 5. So it's that same pattern as a quadratic, but on its side. Okay, so if I go left 2, down 7, so left 2, down 7 should put me right about here. 2, 3, 4, 5, 6, 7, yep. I'm gonna just start that same pattern. Up 1 over 1, up 1 over 3, up 1 over 5. 2, 3, 4, 5. Alternative could count from every single point. Left 2, down 7. Left 2, oops, that one's kind of floating. Left 2, down 7. Left 2, down 7. Left 2, down 7. That's where all those points are coming from. Again, you can erase those gold points if you don't want them. Definitely don't need them. Your final graph is that green graph, and please do not continue this way. Remember, square roots have a very specific domain where you cannot continue. If I plugged in -3 here, this would be imaginary, right? So I don't want to continue to graph towards -3. All right, guys, well, we're going to leave some of these examples, 5, 7, and 8 for class tomorrow. Thank you so much for watching, and make sure you feel comfortable with those shifts within the graph and what each one does.